Okay guys, we have one more example that I want to go through with you. Here we have zinc carbonate, and zinc carbonate is reacting with sulfuric acid to give us zinc sulfate as well as water and carbon dioxide. Now this type of reaction is a little bit different. It is a neutralization or acid-base reaction, but the principles of writing ionic equations will remain the same. Simple and straightforward. Once we follow the rules, we will not go wrong. Okay, so the first thing we need to do is we need to ensure that our equation is balanced. Okay, and if you're able to look and see by inspection, you should realize by now that yes, our equation is balanced. So what we need to do now is we need to go ahead and assign our state symbols. So let's check the solubility for carbonates. All carbonates are insoluble with the exception of potassium, sodium, and ammonium. So all carbonates are insoluble. So that means our zinc carbonate is insoluble, so we'll get the state symbol S. Our sulfuric acid, all acids are aqueous, so that's going to be assigned aqueous. Or zinc sulfate, let's check the solubility for sulfates. All sulfates are soluble with the exception of lead, barium, and calcium. So zinc sulfate would have to be soluble. So zinc sulfate will get the state symbol aqueous. Water is going to be a liquid, and carbon dioxide, as you all know, is a gas. So we have our balanced equation. We have put on our state symbols. So now what we need to do is we need to go ahead and split up those aqueous compounds into their respective ions. The substances that are not aqueous, remember, we are not troubling them. We're not doing anything to them. Those aqueous compounds will not split up into ions. Okay, so our zinc carbonate, we're going to go ahead and put it back as a solid. Our sulfuric acid, we'll have to split it up into ions. What are the ions that make up sulfuric acid? We have H plus ions and we have sulfate ions, SO4 2 minus ions. So we have our H plus ions. How many H plus ions do we have? We have 2 of them. Now please do not write this. Do not. Okay, the way to show that you have 2 hydrogen ions is you put the 2 in front, and then those 2 hydrogen ions are aqueous. Our sulfate ion, our SO4 2 minus ion, is also aqueous. Now we come to our product side. In our product side, we have our zinc sulfate. So the zinc sulfate is going to split up into zinc ions and sulfate ions. So our zinc ions, our Zn2 plus ions, are aqueous. And our SO4 2 minus ions are also going to be aqueous. Then we have our other products. We have our H2O, which is a liquid, and we have our CO2, which is a gas. So now we have our total ionic equation. We have all the ions that are present in the reaction. So let's look for the ions that are not participating now. Well, based on what we're seeing here, you have Zn on this side in a solid state, but on the product side you have Zn2 plus in the aqueous state. You have CO3 solid over here, you have CO2 gas over there. So again, there's a change. You have H plus ions in aqueous solution, but you have H2O on the product side in the liquid state. You have SO4 2 minus ions on the reactant side, SO4 2 minus ions on the product side. So our sulfate ions are our spectator ions. And we remove our spectator ions. We cancel our spectator ions to get rid of them because they are not actively participating in the reaction. So now we can set about writing our net ionic equation. We're going to have our zinc carbonate in the solid state plus our 2 H plus ions. Those are aqueous, giving us zinc ions, so then 2 plus ions. Those are in the aqueous state, plus water, which is in the liquid state, and carbon dioxide, which is in the gas state. So this is our net ionic equation. This is what we want, and we arrived at that by simply following the steps. We write our balanced molecular equation and ensure we have our state symbols. We split up the aqueous compounds into their respective ions, and then we remove the spectator ions. We cancel the spectator ions, and we get our net ionic equation. So what this tells us is that when the zinc carbonate reacts with sulfuric acid, the hydrogen ions are reacting with the zinc carbonate to give us zinc ions or zinc in solution, as well as water and carbon dioxide.